Our project is about remote monitoring of sensor data through hyperterminal. The main aim of our project is to implement a small home security system. The functional requirements of our project are xbee microcontroller, fire sensor, LPG sensor, smoke sensor, PIR sensor for motion detection, 2 xbees for receiving and transmitting of sensor data, PC for hyperterminal, AVR ISP module for programming the microcontroller. This is the main board that we have designed to implement our project. It works on a 5V DC power supply. It has an xbee microcontroller that operates at 3.3 volts, which is obtained from the 5V DC supply using a voltage regulator. The sensors and the xbee are also interfaced with the microcontroller on this board. This is the 3-pin fire sensor module that works on 5V DC. When fire is detected, it gives a digital high output. It can detect fire up to 1 meter. This is the integrated LPG and smoke sensor module used for detecting LPG leakage and carbon monoxide smoke. This module also works on 5V DC supply. Upon detection of LPG or smoke, these sensors give an analog voltage corresponding to the amount of LPG or smoke detected. This is a 3-pin pyroelectric infrared sensor module used for human body detection that helps in monitoring burglars. It also works on 5V DC supply and gives a digital high output upon detection. It has an approximate range of 6 meters. These are the xbee modules used for serial communication of sensor data from the microcontroller on the transmitting side to the PC on the receiving side. Serial data from the xbee is given to the PC through the parallel USB port using a serial to USB converter. This is the AVR in-system programmer used for programming the microcontroller. Now all the modules are interconnected as shown here. The main board and the sensor modules are given 5V DC supply from the first board. The output of the sensor modules is given to the pins of the microcontroller. As the output of smoke and LPG sensors is analog, it is converted into digital form using an inbuilt ADC of the microcontroller. On the other hand, the fire and PIR sensor outputs are already in digital form. The microcontroller is thus programmed to check for a logic 1 from the sensors and to send a corresponding alert message through the xbee to display it on the hyperterminal of the PC. Now let us demonstrate the working of our project. We give a sample of fire to the fire sensor module for detection, and we see that the corresponding fire alert message is displayed on the hyperterminal. We now give a small amount of smoke to the LPG and smoke sensor module, and we observe that the corresponding smoke alert message is displayed on the hyperterminal. Similarly, the LPG alert message is displayed upon detection of LPG. Now when we perform a hand movement in front of the PIR sensor, we see that the corresponding PIR or the burglar alert message is displayed on the hyperterminal. Hence, on receiving the alert messages, necessary actions are taken. Thus, the sensor data is monitored in the home security systems for providing security and protection.